All right, guys, welcome to your study guide for review test number 9. This one is basically going to be a review of how to solve a variety of types of equations. So this is a linear equation. This is an absolute value equation. This is a piecewise function. We've learned a lot of different kinds of functions this year and how to deal with them. So we're just going to revisit how to solve them. Like here's some quadratics. We'll review how to solve quadratics using a variety of strategies. We'll also review how to solve square root functions and functions with weird looking exponents like that. And also exponential functions where the variable is in the power spot. What else are we going to be looking at? We're also going to review how to solve some log equations. This is not a log equation, but you actually do use logs to solve it. This is actually an exponential equation, but you will use logarithms to solve it, so that's why it's in the log section there. But basically, that's it, guys. We're just going to do a quick review of all the different types of equations that we've solved this year. You know, a big part of math and algebra is graphing and solving equations. Our last review test, we reviewed graphing, and on this one, we're reviewing solving equations. So it's a nice little summary. I'm going to be going through the even problems, and the odd problems are provided for you to do, and answers are provided for those if you want to check your work. But without any further ado, let's go ahead and get started here with our first question of the day, a linear function. Linear functions are equations where you have a variable to the first power and that's it. You don't have any weird things like logs or stuff like that involved. It's just a basic equation. The way that I recommend solving those is with an acronym. Don't call me stupid. That's how I've always said it. The D stands for distribute, C stands for combine like terms, M stands for move the smaller x to the other side, and S stands for solve. All right, so here we go. Step 1, let's distribute. So we get 8v plus 48 minus 1. Distribute here as well. We get negative 3v plus 3. After that, you combine your like terms. Right here, we've got a pair of like terms. So we'll put those together. After you're done combining like terms, you move the smaller variable. I've got 8v's on this side and negative 3v's on the other side. The smaller variable is the negative 3, obviously, so I'm going to go ahead and add the 3v to both sides. And that gives me 11v. After that, we have a nice two-step equation that we need to solve, so that's the last step. It's just to solve what you see left. So just go through the regular algebra steps at that point. And we end up with negative 44 equals 11v. Division will give us v equals negative 44. So that's my recommended steps for solving linear functions. Let's go ahead and move on to absolute value functions. So how do we solve these? Well, the first step is you want to get the absolute value by itself. So step 1 is to get rid of outside numbers. So like this 3, I want to get rid of that because it's outside the absolute value. So we'll call that get rid of outside numbers. Now at this step, it's kind of important to check. Do you have a situation like this where you have absolute value of blah, blah, blah equals a negative number? If you ever have an absolute value equal to a negative number, that means there's no solution. So you would stop and say no solution. But in my case, I have an absolute value equal to a positive, so we are going to keep going. All right. Now the next step is interesting. The absolute value of what equals 22? Well, there's two numbers that equal 22 when you take their absolute value. One of them's 22, and the other one's negative 22. So that means that 4 plus 6x can be equal to a negative 22, or 4 plus 6x can be equal to a positive 22. So with absolute value equations, after you get rid of the outside numbers, the next step is to write two equations. And of course, the last step is just to solve both of those. So we're going to minus 4 on both sides. Gives me negative 26. Then we're going to divide by 6. Of course, we do want to reduce if possible, so I get negative 13 over 3. There's one of my answers. And then we do the same thing over here. So minus 4 on both sides. Get 18 here. Divide by 6. And I get x equals 3. So there's my two answers. Very often, absolute value equations will give you two answers. And so you have 3 steps. You have get rid of the outside numbers. You have write 2 equations, and then you have solve. But beware, if you ever have an absolute value equal to a negative, then there's no solution. But that only applies after you get rid of the outside numbers. So let's go ahead and move on to our next type of equation, which is the piecewise function. A piecewise function is a function that is broken up into pieces. So for all the x values less than or equal to negative 2, we're going to use this. And for all the x values between negative 2 and less than or equal to 5, we're going to use this piece. And for all the values of x that are greater than 5, we'll use this piece. So for part A, they're asking us to find f of negative 2. Now, since negative 2 is less than or equal to negative 2, we're going to be using that one there. And since that's the piece we're using, we're going to be plugging that negative 2 into this equation up here. And then we just solve. So this is 4 plus 6 minus 5. And so the final answer there would be 5 if you combine all those together. So you have to look at what number you're plugging in and see which one of these inequalities it applies to, and then plug it into the corresponding piece over here. Let's do one more example. This one says find f of 1. So which one of these is where 1 I can plug in a 1? Is 1 less than or equal to negative 2? No, it's not. Is 1 between negative 2 and 5? Yes, it is. And so that's the piece I'll use for this one. I'm going to be plugging 1 into 4x minus 8. And that will give me negative 4. So you have to just figure out which piece to plug it into, and plug it in, and that's your answer. That's piecewise functions. Let's go ahead and take a look at quadratics. Now with quadratics, you have 3 strategies. There are 3 ways to solve a quadratic. By the way, a quadratic is anytime you have a square on there. Okay, so 3 ways. One way is the quadratic formula. That's the method we're going to do first. Another method is we can, a special kind of quadratic equation, sometimes you can solve it with square roots. And then finally, another way of solving it is with factoring. So there's 3 different methods that we can solve quadratics with. Quadratic formula always works, but in my opinion, it's one of the most tedious ones to use. But it always works. Taking square roots is pretty simple, but it only applies in certain circumstances. Factoring, it's okay. It's not too bad. It's cleaner than the quadratic formula, but it is still a little bit more work. But as I mentioned to you, for this one, we're reading the quadratic formula, and I'll write out the quadratic formula for you now, if you don't remember it. Okay, and that's you're going to use that anytime you have a quadratic that's in standard form and it's equal to 0. The number in front of the x squared, or I guess in this case it's an m squared, is an a. The number next to the m is the b, and the number that doesn't have a variable next to it is the c. And so basically we just plug all these numbers in just the way that they are. You don't plug any variables into the quadratic formula, only numbers, just so you know. So when I plug my b in, I'm just going to put the negative 8. I'm not going to put the m in there. Same thing here. My a is 5, and my c is 11. So that's the first thing you want to do is plug it in. The next thing you're going to do is you're going to simplify pieces. So I'm going to simplify this piece. I'm going to simplify this piece. this piece, and this piece. So the first piece I circled there, negative 8 is positive 8. Next part I circled, negative 8 to the second power is 64. And this crazy looking thing there, what's that? It's 20 times 11, so what would that be? I think that's 220 if I'm not mistaken. And then on the bottom we have 10. Okay? Now the next thing we're going to do is we're going to simplify this square root. And I like to do that on the side just because it does take some time. So let's go ahead and simplify that square root. So the first thing we're going to do to simplify our square root is we're going to do the subtraction. So what is 64 minus 220? Let me punch that in my calculator real quick. It's negative 156. The next thing we're going to do is we're going to break this up. We're going to look for any pairs that we have. Actually, that's not the next thing we're going to do. Just so you guys know, this won't always happen, but if you do ever have a negative in there, you're going to take it out as an I, and that's an imaginary number. Okay? Now, if you don't have a negative in there, you don't put an I. But if you do have a negative, you get an I. So just keep that in mind. You don't always have an I. Now the next thing we do is we start breaking it up. So I know that 156 can be divided by 2. And if we divide that by 2, we get 78. And it turns out that 78 can also be divided by 2. If you divide 78 by 2, you get, let me work it out real quick here, 39. And then 39 can be split up into 3 and 13. And so what we have here as a result is we have the square root of 2, 2, 3, and 13. And square roots, what we do is we look for pairs of numbers that are the same. And as soon as we find a pair, we can write that number on the outside and cross off the pair. Now, if there's no pairs left, whatever's left on the inside, you just multiply it back together and you get 2 square root of 39. And so we're done. That is the simplification of that square root. So now we're ready for the next step. Okay, so now we have 8 plus or minus, and we just found out this whole thing here equals 2 square root of 39 over 10. Now sometimes, by the way, when you're doing this, it's a perfect square root. You won't have anything left inside. In that case, just get rid of the square root. You can actually get some nice answers. But in this case, if you still have a square root left, oh, I forgot my I, by the way. Let's put that I back. That should have been there. My bad. In this case, though, you do have one other possibility. It's possible to reduce. So long as you can do all 3 of them. It can't just be 2 of them. It has to be all 3. If you can find something that goes into all 3 of those, then reduce it. So what can be divided into 8, 2, and 10? Well, all 3 of those numbers can be divided by 2. So if you do that, you would end up with this simplified answer here. Okay? Now, just so you guys know, sometimes you do end up with a negative on the bottom. And if we don't have that here, but if you do, what you're going to do is you're going to take it off the bottom, you're going to move it to the top. Because on a fraction, it doesn't really matter if you put your negative on the top or the bottom. It's the same thing. But just so you know, that the test we're taking won't leave the negative on the bottom. But that doesn't apply here. I was just adding an extra note. So there you guys have it. So what are the steps for this thing? Plug your numbers in. Simplify the 4 pieces that I circled earlier. Simplify your square root. And then reduce if possible. All right. Let's go ahead and move on to the next question. So that's solving quadratics with a quadratic formula. But sometimes you can solve quadratics differently, and you could do it by taking square roots. This only applies if there is only an x squared. So you'll notice that in this quadratic equation, there's only an x squared. There's no x. There's only an x squared. So when that happens, you can do this strategy. And it's nicer. It's quicker. You don't need to do the quadratic formula. What you do first is you start by subtraction. Followed up with a little division. And then solve by taking a square root. Now a couple things to point out here. Those cancel, so you get x. Also, when you solve by taking the square root, you always get a plus and a minus. And when you take the square root of a fraction, you're just going to take the square root of the top and the bottom separately. And so, in this case, you'll end up with 7 over 2. Now, just so you guys know, sometimes these square roots don't come out perfect. So if you ever have a square root on the bottom and it doesn't go away, let's say it was a square root of 3, you have to get that square root off the bottom. We've talked about how to do that many times. Or sometimes when you take a square, it's not a perfect square root, so you have to break it down and take out your pairs. But either way, that's the idea. And there's our final answer. So x is 7 over 2 and negative 7 over 2. So that's the method we use for taking square roots. A third and final method for solving quadratic equations is the method of factoring. Now there are 3 ways to factor. Okay, you have the box method. We've looked at that just recently, I believe. That's where you put it in here and you find the numbers that go on the outside, right? We also have the GCF method. You should always check for a GCF. But box method is if you have 3 terms. So anytime you've got 3 terms, you would use the box method. You should always check for a GCF. Always try to take out what they have in common. And then finally you have the difference of squares method, which just so happens to be what this method is. It only applies to binomials. Okay, and it's even pickier than that. It can't just be any binomial. It has to be a special kind. But these are the 3 factoring methods that we've learned in this class and used pretty frequently, and that's what's going to be used here. So this is what's known as a difference of squares. Why? Because it's subtraction, and both of these numbers are perfect square roots. And so the difference of squares method for factoring looks like this. You're going to take the square root of x squared, which is x, and put 1 there and there. You're going to take the square root of 4, which is 2, and you put 1 here and here. You make 1 a plus, and you make 1 a minus. Okay? The next thing you're going to do is you're going to set each factor, x plus 2 and x minus 2, equal to 0. And you solve each one, and that's how you solve it. Now, you also could have used the method that we learned in the last example. You could have just gotten the x by itself by adding 4 and then taking a square root. Just don't forget your plus and minus. That works also on this one. But just so you guys know, factoring is not always differences of squares. You could have one like this. This would be a box method problem. So be aware, there are different ways of factoring, but nevertheless, when you have quadratics, that is another way to solve. So you have quadratic formula, you have the square rooting method, and then you have the factoring method. The most powerful one is the quadratic formula because it always works. The other 2 methods sometimes work. You can't always factor either, by the way. All right, let's go ahead and take a look at a new type of function, radical functions. And it says, remember to check for extraneous solutions. That's because with these problems, when you're doing the algebra, it turns out that you could actually end up with answers that aren't allowed. So you have to check for those. All right. Well, the big secret here when it comes to radical functions is that to cancel out the radical, you need to square both sides because squares cancel out radicals. And so now we have 3v minus 5 equals 4. After that, you should be able just to solve it like normal. Now, we have to make sure that's not an extraneous solution, though. In other words, I should be able to plug that 3 in here and get a good answer out of it. Let's see. Does it work? It does. We're good to go. Just so you guys know, one of the ways you could end up with an extraneous solution is that after you get your answer, if you plug it, if you get a negative underneath of that square root, that's a no solution problem. You can't have that. So the number that you get as an answer cannot make your radical have a negative on the inside. Otherwise, we would say there's no real solution to it. There's an imaginary maybe, but not a real. All right, let's go ahead and move on to number 14 here. This is another one. It's just that you have some stuff outside of the root this time, and we're going to handle that the way we usually do. You get rid of the outside stuff first. So you're going to add 4 on both sides first. And then you're going to square both sides. And then you're going to solve for p. And once again, you'll want to check your answer, but I think it's pretty obvious that if you took 109 and plugged it in here, it's going to be okay. You're not going to end up with a negative underneath of the square root, so we're good to go. All right, let's go ahead and move along to number 16. These are the types of problems here where you have a root on both sides. Those ones you really got to be careful with extraneous solutions. But in this case, this first step is to square both sides to get rid of the roots. And after that, you basically should have a simple linear equation on your hands. So you'll follow the don't call me stupid steps, the DCMS, distribute, which we don't need to do, combining like terms, which we don't need to do, moving the smaller x, which we do need to do, and then solving. -1. Now we have to make sure that that works. If you plug a -1 into this radical, will it give you a negative underneath? Well, let's see. 2 times -1 is -2, plus 6 is 4. So that's okay. You can take a square root of 4. Or what if you plug it in here? You have to check the other one also. -1 plus 5 is 4, and that's okay also. So we have a good answer. The answer is -1. Just make sure it doesn't make any of your square roots turn out to have a negative under the square root. All right, moving along, let's take a look at number 18. So sometimes we're going to come across these problems with powers that are fractions. When that happens, the main key step to solving these types of equations is to raise both sides to a power. And what power do we want to raise it to? Well, you want to raise it to the same power as this, but flipped over, the reciprocal. So I'm going to raise this to the -4/5 power. And whatever you do to one side of your equation, you're going to do to the other. So why do we raise this to the reciprocal power? Well, because if we raise this power to this power, that means we're going to multiply those, and you end up with 20/20, which is 1. And so you don't really need a power whenever the power is 1. So basically, it's like they cancel each other out. Okay? Now, for these types of problems, a lot of the work is going to happen on this side of the equation, on the right side. First of all, I want you guys to notice that since this is a negative exponent, we have to remember what those do. That's something people forget a lot. What negative exponents do is they make reciprocals. So I can flip this fraction over, so it's just a 243/1, if I change that now to a positive. So if you have a negative power, you can change it into a positive power by flipping your object, your expression over, doing a reciprocal. And just so you guys know, the 1 here is not necessary because anytime your denominator is 1, it's optional, so you don't need to write that. Okay, so now we need to find out what is 243 to the 4/5 power. That's the next step. Well, how do I simplify that? Well, the first thing we're going to do is we're going to rewrite it as a radical. This is something we haven't done in a little while, but when you write these things as a radical, this number here is your root. This number here is your power. And this number goes under the radical. And there you go. So we need to find the 5th root of 243. In other words, what number multiplied by itself 5 times gives me 243? Well, it turns out there's actually a pretty nice answer for that, but I'll still show my work. 243 can be divided by 3. It goes in there 81 times. 81 is 9 times 9, and each of those are 3. So I've got 1, 2, 3, 4, 5 3s. And so the 5th root of 243 can be rewritten as 5 3s multiplied together. So if I want to find the 5th root, I'm looking for a number that's multiplied by itself 5 times. And we just so happen to have that. So for every group of 5, you can write that number outside of the radical and cross off whatever's on the inside there. Now, since there's nothing left under the radical, we can just get rid of the radical completely. So now I've got this 3 being raised to a 4th power. And 3 times 3 times 3 times 3 is 81. And so that simplifies to be 81. So let me erase all that. We'll move on with our problem. We're almost there. But that was the hard part. So we have 5k plus 1 equals, and we just found out this whole thing here equals 81. And from there we just solve it. So the hard part here is the part that I just erased, and that is actually simplifying the root. But there's our final answer. All right, so a couple of interesting things to notice there. When you have problems like this, how do you solve them? Well, the first step is to raise both sides to the reciprocal power. Another thing we saw is that when you have a negative power, you flip this number over and then make the power positive. And the next thing we saw was that you rewrite this as a root and simplify that from there. And so as you guys can see, there's a lot going on in this problem. But after you've done all that hard stuff here on the right side, you have a pretty simple equation to solve. So there it is. All right, let's move on to number 20. This is called an exponential function. Exponential functions are functions where the variable is in the power spot. Okay, now we're going to solve two different types of exponential functions in this lesson. This is the one that we're going to solve it by hand. And then we're going to look at another type in a minute where we solve it with a calculator. Let me see if I can find it real quick. Right here. And you could tell the really ugly ones are going to be calculator problems. You have to use logarithms for them. Also, the question will say round it to the nearest, hundredths or something like that. I think I'm going to go ahead and do number 19 instead of 20 on this one. You guys can do the same. The reason why is because this one's just a little bit harder. And so let's go ahead and do number 19. I'll tell you the answer to number 20 though too, just in case you want to try it and check your work. All right, so for number 19, here we go. Now the first thing that we're going to do is we want to get the bases to match. So get bases to match. Okay, so what do I mean by that? Well, let's see, I'll show you. First of all, I'm going to rewrite that as 16 to the negative 1 power. And I'm going to write this as 64 to the negative 1 power. We don't like these fractions, so we flip them over and give them an opposite power there. It's kind of like the reverse of what we just did on the other problem. Now, I'm going to multiply these together. I distribute the negative 1 on this side, and as a result, we'll end up with 16 to the 3v equals 64 to the 3v minus 2. All right. We still don't have our bases matching though, but we got rid of the fraction and that's good. All right, now I need to get these bases to be the same thing. I don't want this side to be 16 and this other side to be 64. I want them to have the same base number. And these two numbers can both be written as powers of 2. They can also be written as powers of 4, but I'm just going to go ahead and go with 2. 16 is 2 to the 4th power, and 64 is 2 to the 6th power. So now I've got my bases matched. All right, so now we're going to simplify this. So we can multiply that, and we end up with 2 to the 12v power equals, on this one we're going to distribute, and we're going to get 2 to the 18v minus 12 power. After that, we can cross off the bases and just solve what's left because they have the same base, so that's already making the equation equal. We just need to make sure that the powers come out to be equal. So we could ignore the bases and just set the powers equal to each other. And then from here, we just solve it like we normally would. and I end up with v equals 2. So the main step here is to get the bases to match. You'll also notice that I got rid of the fractions at the beginning by giving them negative powers, but that's the basic idea. All right. If you want to go back in your notebooks to our section on solving exponential functions, I think it was Unit 8, if I'm not mistaken. There's a little chart where I give you a list of all the powers so that you can more easily identify what to change these into. Like on the chart, you would see that both 16 and 64, they're in the same column, and both of those can be changed to a power of 2. So if that helps, you can do that. All right, so I'm not going to do 36, but I'll let you guys give it a try. But the answer to this one is -4/3, okay? Let's go ahead and move on to number 21. I'm sorry, I'll do number 22 now. These are log equations now. So when it comes to log equations, there's a couple of different strategies we want to use. But the biggest strategy to keep in mind is that to cancel out a log, you exponentiate. So that's one of the main things you want to keep in mind when solving a log equation. So what does it mean to exponentiate? You're going to take this side and you're going to make it a power of some number. So I'm going to put that whole thing there, log base 7 of 2 minus n. And you can do the same thing on the other side. You're going to make this a power of something. I'll tell you what that something is in just a minute. But basically, you just make both sides of the equation a power of something. And so what is that something? Well, it's whatever number is here. It's 7 in this case. Now, the reason that we do that is because we had a little log property a while back that says that if you have a to the power of log base a of x, the answer is just x. In other words, it's like this and this cancel each other out. Okay, so the 7 and the log 7 cancel each other out, and they leave us with 2 minus n. And the 7 and the log 7 cancel over here and leave us with -3n minus 4. And all we have to do at that point is solve what's left. So the main step when solving log equations is to cancel out the log by exponentiation. After that, it should come out pretty nicely. So I'm going to add 3n to both sides of the equation. Minus the 2. And divide. And there we go. It's important to recognize that, once again, with log equations, you should really check to make sure it doesn't make the inside of the log come out to be 0 or negative, because that's outside of the domain of logs. In other words, it's possible to get extraneous solutions, kind of like what we did back in the square root problems. But in this case, if you plug in -3 here, you get 2 minus a -3, which is 5, and that's okay. And if you plug in -3 over here, you get -3 times -3, which is 9 minus 4, which is also 5, so that's okay. So it works, but you should check for extraneous solutions as well on these. All right, let's go ahead and move on to number 24. Once again, we have numbers outside the log, a 4 and an 8. And just like on all the other problems we've done today, anytime you've got extra numbers outside of the main part of the equation, you want to start by getting rid of those. So I'm going to subtract the 8 first. And then I'm going to divide by the -4. And there's that. Okay, now we're ready to exponentiate. So I want to make both sides of this equation a power of some number. So we're going to make log of 9x minus 2 a power of something. And we're going to make 0 a power of something. And what is that something? Well, it's the base, but notice there's no base here. But maybe you guys remember that when you have a log where the base is not written, that means it's 10. And so that's what's going to go here and here. That's what's known as the common log, is the base 10. So this cancels this, leaving us with 9x minus 2 on the left side. And 10 to the 0 power, that's something you guys may not remember, but any number raised to the 0 power equals 1. So 10 to the 0 power equals 1. And then from there, we just go ahead and solve it. 3 over 9 reduces to 1/3, and we're good to go. And once again, if you want to check your answer by plugging it in to make sure it doesn't make any negatives, that might be a good idea. All right, let's go ahead and move on to number 26. We're going to revisit exponential equations, but this time instead of getting the bases to match by hand, we're going to get our bases to match using two things. We're going to use something known as the change of base formula, which works like this. If you ever have a log base a of b, we're going to rewrite it as log base 10 of b over log base 10 of a. Okay, that's the change of base formula. And to do this, you will need to use a calculator. You won't be able to do it by hand. So we did some exponential equations before. You can tell because they just look a little bit more friendly. These ones we're going to be using a calculator, and you could tell that that's these kinds of problems because they're kind of nastier looking. And also, look, the instructions say round your answer to the nearest 10,000. Only calculators are going to give you those weird kind of answers. So that's another indicator that you're going to be using a calculator. So let's get this part by itself. That's the exponential part. So we have some outside numbers we want to get rid of. I'm going to start by subtracting 6 on both sides. I believe that would be 54.5. And then we're going to divide both sides by 9. And at that point, I'm going to need my calculator because that's a pretty big number. So let me get that out there. 54.5 divided by 9 is some really crazy looking expression, 6.05, and just kind of keeps going after that. So there's that. Okay, so now here's where things get interesting. We're going to log both sides with a base of 13. We're going to log both sides with a base of 13. So we're still going to have 13 to the 1 minus 10r. And we're still going to have 6.05 on both sides. But now we're going to log both sides with a base of 13. Now, why are we doing that? Because there's another log property we talked about earlier this year where if you ever have something that looks like this is another log property, log base a of a to the x, the answer is just x. So it's like these two things cancel each other out. So in this case, this cancels out this, and I'm left with the following. Just the 1 minus 10r now is all that's left on the left side, and on the right side we have the rest of it. Okay, now on the left side, on the right side though, we're going to use the change of base to simplify this. And we're going to use our calculator. So it's going to be 1 minus 10r. And we're going to use, instead of log base 13, we're going to use log base 10 on the top and on the bottom. And on the top, the number in parentheses is going to go up there. And the number on the bottom is the base that we originally had, which is 13. And that's a calculator problem. So you have to type that in your calculator. You just push log of 6.0555. I'm going to put 3 of the 5s there because there's a bar over there. 5 just keeps going. Divided by log of 13. And I get as a result 0.702. Okay. After that, we minus 1 on both sides and just solve it like normal at this point. There's no more weird things to be aware of. So now I've got negative 10r equals negative 0.298. And then we just divide by negative 10. And I end up with r equals negative 0.0298 is my final answer for that one. Okay, and there you guys have it. So there's a lot going on there in that one. And hopefully this is just review for you, right? It should look a little familiar. If I was teaching this for the first time, it'd be really overwhelming. But let's review. Step 1 Well, actually, I think I'll just go ahead and write out the steps here for you if you want to write them down. So step 1 is to get rid of the outside numbers. So this is my basic exponential formula here, and we need to get rid of these two outside numbers. That's step 1. Step 2 is to log both sides, making sure you use the base that they're dealing with. After that, use the change of base formula in your calculator, and then you go ahead and you solve. All right, so for numbers 28 here, what 29 looks like. It's kind of similar, I guess. Anyway, for 28 and 30, we're going to be using the log properties. And you know that you need to use the log properties when you have more than one log on the same side of the equal sign. So I'll say it again here. If you have more than one log on the same side of the equal sign, use the following log properties to put them together. So here's one of our log properties. If you have log base a of m being added to log base a of n, you could put those together as one logarithm by multiplying the m and the n together. That's one of them. Another one, which is the problem we're looking at right now, is if you have two logs that are being subtracted, you could put those together as one logarithm by dividing them. The one that comes first goes on top, and the one that comes second goes on the bottom. And that's the property we're going to use for this particular problem. So here's my first one, here's my second one. So I could put those together as one log by putting the negative 5x on the top and the 8 on the bottom. Okay. After that, you're just going to follow the steps that we've learned before. Let's go ahead and exponentiate both sides. So we're going to have what number to the power of log base 5 of negative 5x over 8 equals what number to the power of 3? And we're using a base of 5, right? So that's the what number is 5. These cancel, and I'm left with negative 5x over 8 equals 5 to the third power, which is 125. After that, you just go ahead and solve like normal. So I'm going to multiply both sides by 8, which gives me negative 5x is equal to, I think I'll choose a calculator. I was going to do it mentally, but I don't want to put something wrong up. So it's 1,000. All right. Then we divide both sides by negative 5. And x is equal to negative 200. And that's it. So if you ever have more than one log on the same side of the equal sign, you're going to use your log properties to solve it. Put them together into one. I think the next problem is pretty similar to that as well. Let's go ahead and take a look at number 30. I think before I move on to the last one, number 30, I'll do number 27 also, because I just want you guys to see one that has addition in it as well, because you could get that on your test, and this is the only example that's like it on your notes. So remember, with addition, you can put them together as one log by multiplying their arguments together. So in this case, I can multiply the negative 4x and the 7 together because my logs are being added. So it's going to be log base 9 of negative 28x. After that, the solving process is pretty much the same. You're going to exponentiate both sides. It's going to be log base 9 is the power on this side, and 1 is the power on this side. These cancel, and so we're left with negative 28x equals 9, and then division will give us our final answer there. So x equals negative 9 over 28. Okay, so with addition, you multiply. With subtraction, you make a fraction. Let's do one more problem. Let's take a look at number 30. All right, well, we have subtraction again. So we're going to put these two logs together by division. So the 3 goes on the top, and the x plus 4 goes on the bottom. All right, step 2, let's exponentiate. So if I make both of these sides a power of 9, then the 9 cancels out the log here and here, and leaves me with just this equation. And then from there, we're going to solve this equation. Now, how do you solve this? Well, we're going to multiply both sides by the denominator. Why do we do that? Because now these cancel. And that leaves me with 3 equals 78 times x plus 4. And we just need to distribute here. So that's going to be 78x plus a really big number, 78 times 4. What is that? 312. And from there, we're just going to solve for x. So I'm going to move the 312 over. Negative 309. And then divide. And it doesn't look like it goes in there evenly, but it can be reduced. I think 3 goes into the top and the bottom here, so let's reduce by 3. All right, and so there's that one, 103 over 26. All right, guys, so that's it. We talked about how to solve a variety of different types of equations that we've looked at this year. A lot of different strategies and possibilities for different types of equations. So hopefully that's helpful, and we'll see you guys in class for your review test on solving equations. Have a good one.